Find each measure. Part A, CD. Looking at the diagram, you are given that line segment AB is congruent to line segment BC, and that line BD is perpendicular to line segment AC. So by definition, line BD is the perpendicular bisector of line segment AC. So by the perpendicular bisector theorem, AD is equal to CD. Because AD equals 27, CD equals 27. So CD equals 27. Part B, PR. Looking at the diagram, you are given that PS equals RS, and that line SQ is perpendicular to line segment PR. So by the converse of the perpendicular bisector theorem, line SQ is the perpendicular bisector of line segment PR. Then by the definition of segment bisector, PR equals 2 times PQ, which equals 2 times 5, which equals 10. So PR equals 10. Part C, GH. Looking at the diagram, you are given that GF is congruent to EF, and line HF is perpendicular to line GE. So line HF is the perpendicular bisector of line segment GE. So by the perpendicular bisector theorem, GH equals EH. You can substitute the given information into your equation, which gives 3x minus 8 equals 2x. Subtracting 2x from each side gives x minus 8 equals 0. Then adding 8 to each side gives x equals 8. Now substitute 8 back into the equation for GH. So GH equals 3 times 8 minus 8. Multiplying 3 and 8 gives 24 minus 8. So GH equals 16. Is there enough information given in the diagram to conclude that point L lies on the perpendicular bisector of line segment KM? Yes, there is enough information. Looking at the diagram, you are given that line segment LK is congruent to line segment LM. So because point L is equidistant from the endpoints of the line segment KM, you can use the converse of the perpendicular bisector theorem. So by the converse of the perpendicular bisector theorem, point L must lie on the perpendicular bisector of line segment KM. Find each measure. Part A. The measure of angle ABC. Looking at the diagram, notice that line segment AD is perpendicular to line segment AB, and line segment CD is perpendicular to line segment CB, and AD equals CD. So by the converse of the angle bisector theorem, ray BD bisects angle ABC. So the measure of angle ABC equals 2 times the measure of angle CBD. And you are given the measure of angle CBD in the diagram, which is 56 degrees. So that gives 2 times 56 degrees, which equals 112 degrees. So the measure of angle ABC equals 112 degrees. Part B, JM. Looking at the diagram, you are given that line segment JK is perpendicular to line segment JM, and line segment LK is perpendicular to line segment LM, and ray KM bisects the angle JKL. So by the angle bisector theorem, JM equals LM. You can substitute the given information into your equation, which gives 4x equals 2x plus 12. Subtracting 2x from each side gives 2x equals 12. Dividing by 2 on each side gives x equals 6. Now you can substitute 6 into the original equation for Jm, which gives Jm equals 4 times 6, which gives Jm equals 24. A pair A parachutist lands in a triangular field at point P and then walks to a road. Will he have to walk further to Wells Road or to Turner Road? Neither. Looking at the diagram, point P lies on the bisector of the angle between the two roads. So by the angle bisector theorem, point P is equidistant from the two roads. So the distance to both roads is the same. So the parachutist can walk to either road and he will walk the same distance. Write an equation of the perpendicular bisector of the segment with endpoints d 5, -1 and e, -11, 3. By definition, the perpendicular bisector of line segment DE is perpendicular to line segment DE at its midpoint. So find the midpoint M of line segment DE. The coordinates of M are 5 minus 11 divided by 2, negative 1 plus 3 divided by 2, equals M, negative 6 divided by 2, 2 divided by 2, which equals M, negative 3, 1. And the slope of line segment DE is negative 1 minus 3 divided by 5 minus negative 11, which equals negative 4 divided by 16, which equals negative 1/4. So the slope of the perpendicular bisector is 4, because 4 times negative 1/4 equals negative 1. So use slope-intercept form to find the equation of your perpendicular bisector. Plugging in the midpoint and the slope gives 1 equals 4 times negative 3 plus b. Simplifying gives 1 equals negative 12 plus b. Adding 12 to each side gives 13 equals b. So the equation of the perpendicular bisector of line segment DE is y equals 4x plus 13.